Hello guys, we are back with our next lecture. In this lecture, let us go through the next topic. So the topic name is threads, guys. So in this lecture, we'll be going through the overview about threads and multi-threading. So single thread and multi-threading. So this is an interesting topic, right? Yes. Okay. So the thread is nothing but the smallest block of code, guys, and it is popularly called as a lightweight process. Okay, so let us go through the definition which is written here. So a thread is a basic unit of CPU utilization, consists of a program counter, a stack, a set of registers, and a thread ID, which is called as a lightweight. So basically thread is nothing but a lightweight process, guys. Okay, whereas a multi-threading is an application which is having multiple threads within a single process. Okay, so basically the thread structure will look in this way, guys. So a thread is going to have code, data, files, register and stack. Okay, so these are the things which a thread have. But if you perform a multi-threading, so in that we are going to have multiple threads with the same code, the same data, the same files, each with their own registers and stacks, guys. Why I am saying exactly the names and everything is because you can get a direct question from this topic, guys. So the thing is, most of the time whenever the examiner wants to cover this threads topic, he will give true or false, guys. In 4 options, like 2 options he will give about this thread concept, and in other 2 he will give some other topic. So in that way, every time he will cover, guys, almost, we can say. I don't remember whether it came in 2021 set 1, but there could be a chance, right? I don't remember that much, right? Because MSQs will be forgetting easily. Okay, yes. Okay, so if it is a single thread, it is going to have its own code, data, files, register, stack. If it is a multi-threading, it is going to have common data, code and files and separate registers and stack. Okay, okay. But the major thing that you should remember is computer or the CPU doesn't know that this is having multiple processes, guys. Remember it. So it is known only for you and me. That's it. The computer doesn't know. Computer thinks that there is only one thread or this is a single process. But it is internally containing 3 threads. Got it? Yes. So the advantage here, the problem here is, so if one thread gets blocked or in waiting, all the other threads are blocked. So assume that these 3 are in a group now, right? Yes. So if this guy did some mischief, so basically that mischief is done by this whole process, right? Means this whole process will be blocked. So because of this guy, these 2 guys will also affect. So that is a disadvantage here. Got it? Yes. So and the CPU utilization will be less, guys. Okay. Yes. So the above threads which I have discussed are the user level threads, guys. Okay. Yes. So let me be clear with you. So there are total 2 types of threads. So the first type of thread is a user level thread and the second type of thread is a kernel level thread, guys. Okay. So user level thread is nothing but, so inside this threads we can have multiple threads, guys. Okay. But CPU doesn't know that. We are not informing to CPU. CPU thinks that it is only one thread. Okay. So user level thread known only to user. So only we know. Sorry for that, guys. Okay. So only we know about that thread, guys. So that is a user level thread. So only we know. So CPU thinks that it is only a single process. It doesn't know that there are hundreds or thousands of threads inside. Got it? Yes. And no scheduling individually. So basically because the CPU doesn't know that there are 100 threads inside, so it is going, there is no scheduling. So it is going to give the chance to anyone and it will think that whole thing is one process only. Okay. And the issue here is, so if one is blocked, then everyone will be blocked, guys. That is a major disadvantage here, right? Yes. And the advantage here will be context switching will be really fast, right? Because if I am working with this particular thread now, after some time I will work with this, after some time I will work with this, I can swap anytime I want. So that's a huge advantage, right? Yes, that is an advantage. So when it comes to kernel level thread, so this is other type, so which is known to our CPU. Okay, so in simple words, kernel is nothing but a CPU, guys. You can think in that way, okay? Because kernel is a part of CPU, okay? Yes. So this kernel level threads are known to CPU. Okay, so here scheduling takes place. So basically if there are 10 threads which are known to kernel, it is going to order them. So first you done, you go, then you go. So in that way, okay. And similarly context switching will be low because kernel is involved, right? He will say, you do, then you do. So he will take some time in thinking and all those things, right? Yes. And if someone is blocked, only he will be blocked. So this is an advantage, to be clear, right? Yes. So this is all the concept that you should learn, and there are almost around 10 questions, over 10 questions, just based on this page, guys. If you are clear with this page, you can solve those 10 questions, guys. Because those are just true or false. You can just say that whether they are true or false. That's the major thing here. Okay. Yes. Okay, so now let us go through some models of these threads, guys. So these are the three popular models. So the first model is a many to one, the second model is one to one, the third model is many to many. Okay, so the first model is many to one. So basically many user threads will act as a single thread to the kernel, guys. So this is what we discussed, right? Yes. So here we are having 4 threads, but for CPU it thinks that that is only as a single thread. So that is many to one, guys. Similarly, one to one. So one thread will be treated as one thread in the kernel. So this is one to one. Similarly, many to many. Okay. So here there will be no clarity, guys, to be clear, because we don't know which thread is which, but each of them will be known as its own thing, and there are multiple ones. The only catch here is the above part. You can have multiple threads, but below should always be greater than or equal to this, guys. So basically above value, that is nothing but user level threads, should be greater than or equal to kernel level threads. Got it? Yes. So now I hope everyone is understanding the concepts, right? Yes. So this is all about the threads, guys. Got it? Yes. So now you are getting the idea, right? So it's almost clear, right? Yes. So please practice this particular thing, guys. I'm 100% sure that 50% of the students will do silly mistakes in this topic, guys. So that is the reason why examiner always tries to give a question from this. Got it? Yes. So please practice these things, and while solving PYQs, I will be making you to practice, so don't worry. Okay. Yes. So this is the last topic with respect to operating system, guys. So in the next lecture, we are going to start solving the PYQs, and once the PYQs are done, we will be moving on to the next subject. Next subject will be database management system, DBMS. Okay. Yes. So I hope everyone is understanding all the things which we are discussing, right? Okay. Yes. So I hope everyone is getting clear idea. So in the next lecture, let us continue with the PYQs. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.